Okay, Bismillahirrahmanirrahim. Assalamualaikum. Okay, today we look into the next chapter, properties of professional logic. This one, basically, when you talk about the properties, it defines the operation inside the definition. And then for the professional logic, this one, okay, this one is just revision. Just a revision from your discrete mathematics, that professional logic, also called as professional calculus, is a statement logic. It deals with the proposition, and then it deals with the operation and also the relation between the proposition, including the construction of the argument based on them lah. And then we have first we have implication. Implication, negate A or B implies A implies B lah. This one is an implication. Implication logic. Okay, implication in logic is a relationship between two proposition. This one is a relationship between two proposition. So we have implication. Okay. Okay. This one same goes if we see negate A or B implies A implies B lah. Okay, the second logical consequence of the first. In most of the formal logic, a broader relationship called material implication is employed, which read if A then B. If A then B. Okay. Okay, this one implication. Okay. Okay, do you have any question? Ada soalan ke? Okay. Example. Give you example. Example is suppose we have example. Suppose we have the sentences. Sentences A and B. Okay, A we assign as the sky is overcast. Okay, B, the sun is not visible. Using the above sentences as example, we can say that if the sun is visible, then the sky is not overcast. Okay. Okay. Implication. Implication is the relationship between two proposition, which the second is logical consequences of the first lah. Okay. Okay, this one. Uh, the second is second is logical. So we can say that the sun is not visible. Uh, then the sky is not overcast lah. Okay, we go by the B and then A lah. Okay. So this one implication. Okay, do you have any question? Implication? Ada soalan ke? Okay, if you don't have any question, we go by the contraposition. Okay, contraposition logic. I think it. Contraposition is a form of immediate inference, which a proposition is inferred from another, and where the former has for its subject the contradictory of the original logical proposition predicate. Okay, if you look here, if A implies B, equivalent to negate B implies negate A. Okay, it is the form of immediate inference. Okay, this one is immediate inference. Inference. From another. Okay, example. Okay, for example, consider the statement if it is raining, then the grass is wet. To be true. Example, if it's raining, then you can assume that the positive or contraposition statement. Okay, this one contraposition, contrapositive. if if the class is not met, then it is not. Okay. It is contra. If the grass is not wet, then it is not raining. It is also true. Lah. Okay, this one true. Lah. Okay, do you have any question? Boleh ke? Aiman? Aiman Rashid boleh ke? Boleh eh? This one is number 2 lah. Okay. And then we have equivalence. Okay. Okay, if you look at the equivalence, A implies B and B implies A is equivalent to A uh, equivalence to B lah. Okay, same. In logic and mathematics, please uh, be reminded that the statement P and Q are said to be logically equivalent if they are same truth value in every model. Okay, and equivalent. Okay. You can see that statement P and Q. Okay, equivalent if they have okay. Okay, example. I give you example. KP implies Q is logically equivalent to negate P and Q. Okay. Okay. Another example. If number is a multiple of 4, then it is even. It's equivalent to a number is not multiple of 4, or else it is even. Okay, this one number 1. Okay, number 2, we have if a number then it is even. Okay, is equivalent equivalent to, okay, if, okay, a number is not okay. If a number is multiple of 4, then it is a set. It is even. It is even. Is equivalent to a number is not multiple of 4, or else it is even lah. Okay, boleh? Melissa boleh? Tak boleh. Okay, and then we have the law. We have the Morgan law. Okay, is expression of equivalence statement. Okay, we have negate A and B is equivalent to, we open the bracket, negate A or B is De Morgan law is contradict with the equivalence. Same goes if you have negate open bracket A or B is equivalent to negate A and negate B. This one is De Morgan law, vice versa. And then we have a distributive law. Okay, and A or B and C is equivalent to A or B, and okay, we uh, put the operation here to here. Okay, okay, we have A or C lah. Okay, okay, same goes to A and B or C is equivalent to A and B, or uh, A and C lah. Okay, and then we have tautologies. In tautology, is a formula or assertion that is true in every possible interpretation. Okay. Okay, for example, if x equivalent to y, or x is not equal to y, similarly, either the ball is green or the ball is not green, it's always true regardless of the color of the ball. Okay, for example, we have this one is for tautology. Okay, this one tautology. Okay. Okay, from the example, either the ball is green or the ball is not green. It is always true. Regardless of color of the ball. Okay. Okay, and then we have a contradiction. Contradiction. Okay, contradiction is occurs when a proposition conflict either with itself or established fact. Okay, it's often used as a tool to detect the disgenius belief and bias. Okay, example of a contradiction in logic. Okay, for example, every S is P and some P is not, some S is not P. Are contradictions. Okay, example, contradiction. Mm, okay, okay, this one is contradiction. Okay, and then we have okay, contradiction A or F equivalent to A and so on. Okay, this one contradiction. Okay, the step taken for proof by contradiction also called indirect proof. Contradiction, or sometimes we call it as indirect proof. Okay, indirect proof. Okay, so far ada soalan ke? Do you have any question? Is it okay? Boleh ke? Fitri? Fitri Syahir boleh ke? Okay, then we go by the satisfiability. Okay, satisfiability basically. Okay, formula is called satisfiable if it is true for at least one interpretation. In mathematical logic, particularly first order logic and propositional calculus, satisfiability and validity are elementary concepts of semantic. Formula is satisfiable if there exists a model that makes the formula equivalent to true. Okay, and then logically valid or simply valid if it is true for all interpretation. True for formulas are also called tautologies. This one is association between satisfiability and tautologies. Okay, and then unsatisfiable if it is not true for any interpretation. Okay, and then every interpretation that satisfy the formula is called a model in the formula. Okay, and then we have in logic and computer science, the Boolean satisfiability problem is the example of problems. Okay, it is a problem of determining if there exists an interpretation that satisfies a given Boolean formula. Okay, example. Example here. Okay, Boolean. Okay, this one is the problem. Boolean satisfiability problems. Okay. Sometimes it called SAT, satisfiability. Sometimes the shorten is SAT. Okay, for the satisfiability, Boolean satisfiability problem, sometimes we call it as B-side Boolean. Okay. Okay. Basically, when you want to make a proposition satisfiable, compound proposition P is satisfiable if there is a truth assignment that satisfies P. No? That is at least one or entry of the truth table is true. A compound proposition P is unsatisfiable or a contradiction if it is not satisfiable. Okay, this one is a proposition for satisfiable problem. Okay. Okay, then we have another one. We have entailment. Entailment. Entailment in logic. Okay, logical consequences is fundamental concept in logic, whereby it is describe the relationship between statement that hold the truth values when one statement logically follows from one or more statement. Okay, so we have deduction theorem. We have proof by contradiction, and then we have a formula knowledge space that entail a formula. Okay, the rule is simple. The basic rule for entailment has been effectively captured by example. For example, if two sentences X and Y are related by entailment, then it means that if X is true, then Y must be also be true. Okay, I explain more. Okay, this one entailment. This one is definition, the relationship, statement, or when one statement. Okay, example. Okay, if You have two sentences, X and Y. Are related. Okay, we can say that if X is true, then Y must also be true. Hmm? Or conversely, that if Y is false, then X must be also false. Or otherwise, we can say that if Y is false, then X must also be false. Okay. Okay. Do you have any question? Ada soalan ke? Boleh ke? Junior? Ilya? Ilya boleh Ilya? Ilya Fatihah? Okay, in other words, if you see the entailment, it is more likely uh, on the relationship between sentences, whereby one sentence will be true if all the others also be true lah. If let's say the others is false, then the statement before that must also be false lah. Okay, logically follows. The entailment is logically follows the statement. Okay, okay. What is the difference between entailment and implication? Okay, implication is something that may be true or false depending on which truth assignment that you are considering you are given at the moment, whereby the entailment is statement about all the truth assignment. Okay, this one is differences between implication and entailment. Okay, before this we have discussed the implication versus the entailment. Okay, when we said about the implication is something that may be true or false, depending. Okay, this one depending on truth assignment. Okay, whereby the entailment is statement about entailment is about the all about truth assignment. Okay, Okay, this one is differences between entailment and implication. Okay, but when you said about the implication, it may be true, may be false, depending the assignment that you give, the statement that you give. Okay, okay. My question is, how do you want to identify the entailment? Siapa ada ni? Who want to answer? Mama Aziz boleh ke? Mama Aziz, Khairil Ami ada? Khairil Ami, Khairil Ami Zakaria ada ke? Yeah, how you want to identify the entailment? Ni tidur lah ni. Macam mana? How? Okay. The question is, how do you okay, basically when you go about the truth assignment, you must pay attention to conditional statement. Okay. And the other one is strong premises, logically strong premises. Okay, example, one logically strong example, such as all and must statement. This one such as all and must statement. Okay, because you are considering the truth assignment. Okay, boleh Hari Amir? You can call it all and must. Okay, then we have sound. Okay, this one is associated with the entailment, entailment. But if you said about sound, sound in logic, meaning that more precisely in deductive reasoning, calculus is called sound if every derived proposition follows semantically. It is if it holds for knowledge space and Q that okay complete. Okay. Uh, the argument if it is called a sound if it is both valid in form and premises are being true. Okay, this one give you the simple definition. Sound in logic. Argument is sound if True. Okay, what is example of sound argument? A sound argument is one of is not only valid but begin with premises that are actually true. Lah. It is same and more likely like uh, equivalent, equivalence and entailment. By this one, uh, okay, I give you another example of sound. Sound logic. Okay, for example, all dogs are mammals. Okay, the statement that I give to you, argument contain the true premises, but it is invalid since the conclusion doesn't logically follow from the premises. Therefore, it is also called unsound. Unsound. Okay? Okay, this one is we call it as unsound. Unsound. Okay, if you want to give the okay, I give you another example. Okay, okay, it is unsound. Okay, another example for sound. Okay, if it is snowing, then it is cool. Okay, this one is sound. Why? Because valid argument is argument which the conclusion must be true whenever the hypotheses are true. In this case, a valid argument, we can say that conclusion follows from the hypothesis. Okay, conclusion. We have the conclusion here follows the hypothesis. Okay, this one hypothesis, this one conclusion. Ingat lagi tak, Aziz? Nazifah ingat tak? Hypothesis and conclusion. Sheila ingat lagi ke? Nur Sheila. Okay, but here when you uh, see, this one is hypothesis, this one is conclusion. The conclusion is not follow the hypothesis. We name it as unsound. Okay, but when okay, if it is knowing for the hypothesis, then it is called the hypothesis follows the conclusion. This one is not follows. We name it as unsound, but if it is post valid, okay, equivalence, we name it as a sound. Okay, we take 5. Sekejap lagi kita sambung. Okay, ada soalan ke? Do you have any question, Anis? Boleh ke, Anis? Boleh ke? Okay, okay, this one. Okay, for the sound argument. Okay. Uh, it must meet the two criteria to make it sound. Okay, first one, it is valid. Nanti ada yang complain. It is must be valid. And secondly, it premises are true. So, in other words, a sound argument and right form and it is true. Okay, sound argument. Okay, same goes here. If the conclusion or premises, one of the premises is false, mean that it is not sound, or we can call it as unsound. If both premises were false, it will of course still be unsound. Okay, another example I give to you. Okay, we can have P for JC is my husband and Q I'm a JC wife. Okay, we have P. Okay, JC my husband. Okay, and then Q, I am JC wife. Okay, then we assume P P is true and Q also is true. Then we have either JC is my husband or I am a JC wife. Okay, if you see that I am not a JC wife, therefore JC is my husband. So it is technically still valid or sound. Can tell the difference. Both premises are true, but the conclusion is false. It should invalid. Okay, so your unsound. Okay, we have unsound argument have or false conclusion. Your unsound argument has a true conclusion P. JC is my husband. Mine above has a false conclusion. Okay. Okay, JC is my husband is unsound because it is uh, false premises. If you have if you want to have a sound, you must have a valid argument for both P and Q. Okay? But here is sound because we assume that P is true and Q is true. So it is unsound if P JC is my husband. But here we conclude that assume P is true and Q is true for both P. So for both P and Q, true. Okay, it is a sound. Okay, you okay? Boleh, Lia? Fatin? Fatin boleh ke Fatin? Ha, tak boleh? Okay, next week we go by the CNF. CNF. Okay, I give you another example. Okay, we have premise one. All is normal. Okay, and then we have premise two. Killer will is aware. And then we have premise three. Oh, and then we have conclusion. What is the conclusion? Aliana? Aliana Akila? Apa conclusion dia? Ha, apa macam mana? Macam mana ni? Therefore, killer whale is a mammal. Pandai. Okay. Okay, you must remember what is sound argument. Argument must fulfill two requirements in order to be considered as sound. One requirement is that the argument must be valid, that I stated before this, and argument is valid when its conclusion follow logically from the premises. This one we have hypothesis. You have learned hypothesis and conclusion. Okay, the hypothesis must follows the conclusion. Okay. In other words, it is impossible for the premises of an argument to be true when the conclusion is false. So the second requirement is that all premises should be true. The second requirement, okay, thus a sound argument is valid that has a true premises. Okay, okay, please do this exercise, whether it is sound or not. Okay, ini siapa nak jawab? Fatih Aizati boleh jawab? Boleh jawab? Please explain this one. All cat are pink. Toffee is a cat, therefore Toffee is a pink. Please answer. Fatihah, apa lama sangat ni, senang je. Ni sound ke? Sound ke unsound ni? Sound. Mana soundnya? This is a valid argument since the conclusion logically follows from the premises. However, the first premises is not true. This one is not true. Semua kucing warna pink ke? Habis tu? Macam mana dia boleh pink? Okay, all cat is not pink, not true. This one true. So, this one is unsound. Okay, unsound. Okay, another example. Siapa nak jawab ni? Nurul Syafiqah ada? Nurisa, Nurisa boleh? Nurisa boleh? Siap, saya tulis ya. Ah, okay, please explain. Ah, why? Apa dia? Tak dengar. Sebab, okay, the above argument the argument contain true premises but is invalid in the conclusion doesn't follow from the premises. Okay, we have a hypothesis and then we have a conclusion. Then the hypothesis is not follows the conclusion. So this one is unsound. Okay, good. Okay, unsound. Okay, please remember, sound argument is argument that is valid and has two true premises, while unsound argument is an argument that it is invalid and has at least one false premises. Hence, this is the key difference between sound and unsound argument. Therefore, a sound argument always has true premises and true conclusion, whereby the unsound argument may have both false and true premises and conclusions. Okay, so we can draw the table. We can draw the table to conclude what we learned today. Okay, uh, okay, argument. Then we have definition. Okay, we have premises, and then we have validity. Okay. Sound argument is valid and has true premises. Okay. Whereby unsound argument is invalid and or has at least one false premises. Okay. And then for the premises, we have always true. Okay, this one at least one is false. Okay. And then the validity always valid. And then for this one, maybe valid or invalid. Okay. Okay. Clear? Sila, boleh? Aiman? Aiman Nasir? Boleh ke? Clear tak? Ke tak clear lagi? Ke tak clear lagi? Tak clear, saya bagi example lagi. Okay, I'll give you another example. Okay, I'll give you another example. Okay, ada apa ni? Oranges are green. All green. Green. Therefore, oranges. Okay. Yang ni Nur Akila Ismail jawab macam mana? Yeah. First, you need to think it is valid or invalid, and then please apa? Please tell me it is sound or unsound. Macam ni? Okay, unsound. Valid or invalid? Invalid. You valid. Okay. Because the validity is maybe valid or invalid. Okay. Sebab dia ada satu je yang false. Dia oranges are green false. Jadi dia invalid lah. Dia valid. Sebab bila salah satu is if one is invalid, one is valid, it is valid. But this is not this is unsound. Okay, this one invalid. Invalid statement. I give you example of invalid. This one valid. Okay, I give you another invalid. Will know how to play hockey. Therefore, Yang ni invalid because yang ni why valid because the premises apa follows the conclusion. Okay, this one is valid because the premises follow the conclusion, but here the premises doesn't follow the conclusion. Boleh Akila? Okay, I think that's all for today.